Hello guys, I'm going to deliver chapter 5 alcohol. This chapter have two videos. So, the first video consists of part 1, 1.1 and 1.2. Based on the learning outcome, I'm going to discuss 5.1 which is nomenclature and 5.2 physical properties. You guys can read details of the learning outcomes through your tutorial booklet. Before we go further, let me introduce you what alcohol is. Alcohol is a class of compound that has hydroxyl group attached to it. So the general formula can be written as ROH, and we can divide it into two classes. The first one known as acyclic. Acyclic is when the open chain attached with at least one hydroxyl group. Example here is 2-butanol. Meanwhile, for the cyclic is the closed structure bonded with hydroxyl group. Example here is cyclohexanol. So for the learning outcome, you should be able to draw and name structures of alcohol according to the IUPAC nomenclature and classify them into primary, secondary and tertiary alcohols. Basically, there are three basic steps in naming alcohol. Step 1. Number the longest carbon chain so that the carbon attached to the hydroxyl group is given the lowest possible number. Here is the example. After we find out the longest carbon chain consists of 8 carbons, so we number it. Since there are 8 carbons in alkane, we name as octane, but when we turn it into alcohol, so we drop the final E from the alkane and replace with suffix -ol to give the parent name. So octane will become octanol. Step 2. Name all the substituents present in alcohol molecule and indicate their position. There are 3 substituents there. All of them are methyl. 2 of the methyl attached at the second carbon and another one methyl attached at the sixth carbon. And the last step, step 3, we're going to arrange all the substituents alphabetically and combine them with the parent name. So the name is 2,2,6-trimethyl-1-octanol, or we can name it as 2,2,6-trimethyl-octan-1-ol as well. Classifications of alcohol. There are 3 different classes of alcohol. Primary alcohol is when hydroxyl group attached to the primary carbon. So as we can see here, this hydroxyl group attached to this carbon. This carbon is primary alcohol due to have one alkyl group attached to it. Example is ethanol. For the secondary alcohol, hydroxyl group attached to the secondary carbon. So from the structure here, we can see this hydroxyl group attached to this carbon. This carbon is a secondary carbon because there are 2 alkyl group attached to it. So the example is 2-propanol. And for the tertiary alcohol is when the hydroxyl group attached to the tertiary carbon. So from the structure here, we can see the hydroxyl group is attached to this carbon, which is this carbon is bonded with 3 alkyl group. The example here is 2-methyl 2-butanol. Part 1.2. So the learning outcome in this part is compare the boiling point of alcohol within successive members and with alkanes. Compare the solubility of alcohol in water. For the preparations of alcohol, we are going to discuss it in the second video. So wait for it. So we start with boiling point. The presence of hydroxyl group in alcohol provides the strong intermolecular hydrogen bonding interaction. Therefore, alcohol have high boiling points. As you can see here, one alcohol molecule will interact with other alcohol molecule with the dotted line. The red dotted line is known as hydrogen bond. So when we compare the boiling point of alcohol with successive members, we can see the increasing boiling point based on the increasing of molecular weight. So from the table, we can see the boiling point of methanol is 64 degrees Celsius, followed by ethanol 78 degrees Celsius, and the highest is butanol with 97 degrees Celsius. Boiling point of alcohol increases with the increasing molecular weight due to the increasing in van der Waals forces between molecules. So, when the molecular weight increases, surface area also increases, and hence the van der Waals forces increase. The second is we compare the boiling point of alcohol with alkanes. Based on the table, we can compare ethanol and propane, which have the molecular weight about the same. So in this case, the boiling point of alcohol, which is ethanol, is higher than the propane. So what we can explain is alcohol have higher boiling point than alkanes with similar molecular weight based on the presence of hydrogen bond between molecules. So it will cause the strong intermolecular forces. Alkanes are nonpolar molecules. Therefore, they only form weak van der Waals forces between molecules. The second physical properties of alcohol is solubility. Normally, alcohol are soluble in water because they can form hydrogen bond with water molecules. Solubility decreases with increasing molecular weight because of the bigger hydrophobic area effect. So as we can see here, there is interaction between the water molecule and the alcohol. So this alcohol is surrounded with water and the hydrogen bond can be formed.